All right, so let me get rid of that. I don't need this anymore, I think. Okay, so let's see, the question was, you have like 3 or 4 questions. The first question is, you already given a relational model with set of tables, and also primary key for each table is underlined. I don't know whether you can see the underline here. Let me try to amplify this. Okay, so it's better, right? Good. And then say employee table have ID as a primary key, and e-name, street, city, birth date, and hire date. So none of those, can be like a primary, can be foreign key, right? And then there's a table called works. The works table has employees, so that is a foreign key, right? Because that is reference to ID for employees table. And then company, that is also a foreign key. So that is actually reference to that company name for the company's table. And so essentially this one, the works is a gerund, okay? It's gerund between employees and the companies, all right? And then I made a mistake. So employees supposed to be part of the primary key. However, I did not underline that. So some of you identified that correctly, but if you did not, that's fine. So when you're writing SQL statements, if you just say company is a primary key, I did not take that as a mistake, but since I did not underline it correctly, okay? So that part is fine, but however, this table does have 2 foreign keys, employee table, employees, and also companies, right? The company table, company name is a primary key, and no foreign keys. And then managers, so managers, employee ID and a manager ID. So apparently they both are foreign keys. So this is actually like a recursive relationship for employees. It's a many-to-many. So many-to-many recursive relationship. So you create a junction table. So manager is actually junction table for that. Okay. So the question identify foreign keys for each relation, if there's any. So basically, just point out that works has 2 foreign keys, companies have 2 foreign keys. If you made any mistake, then each one will be like a 2.5 points be taken off. And then you write SQL statement to create these tables, and then make sure each table has appropriate primary key and the foreign keys. I think the mistake you probably will make, not everyone, just few people made a mistake in one person made a mistake on referential integrity rules. For example, if you have company name defined as a char, like a 15, then this company foreign key must be also char 15. If you violate that rule, 2 points will be taken off. But then for other type of mistakes, if you, for example, you miss like a foreign key, you do not identify foreign key, that will be 1 point taken off. Okay, so in total, like 5 points for this SQL statements. And let me say whether you need me to write complete SQL statement or not. I don't think, I think almost everyone just get that right, except a minor mistake in identifying foreign keys. So for example, company has 2 foreign keys, so you have to say 2 foreign, not company, manages have 2 foreign keys, so you have to say this 2 foreign keys separately. You cannot just say employee ID as a foreign key, but manager ID is not a foreign key, okay? So if you somehow identify that correctly, say this is foreign key, however, inside your code, you did not do that, and then maybe 0.5 point will be taken off. Okay, so that's, I will consider those kind of minor mistake. All right, and then we get into like 3 modification statements. So basically, you need to use alter table statement to modify, to add constraints, or all of them are add constraints, I believe. Okay, so basically, what you need to do is just write constraint. Let me just do one or two, maybe. Maybe first one, the second one. Okay, so let's say if I'm going to do the state. The state which one has state? Companies, right? Companies have a state column, so you need to change that out of that table. So let's do whiteboard. So let me put these questions in front of us. Okay. So you're going to do, say, you're going to change, so modify above statement to implement the following business rules. So all this will be constraints. Okay, so you're going to say alter table companies. Okay, so you're going to add. Okay, then you can say constraint. Just give a name. So let's just say this is check constraint, check state. Okay, that's a name. And then you say check. And then you put parentheses around it. So what it is essentially check is that you make sure that state is in this list. So the list have list of values. So that's PA, and then single quote Ohio, and then single quote NY. So you put the list inside the parentheses, separated by commas, and then you just want to make sure that this state is in this list, and semicolon. Okay. And then second one, if you want to do second one, so you're going to change salary and make sure the salary is either missing value or non-negative value. So in other words, if you're trying to put a value into the salary column, you have to have a negative, non-negative value, or you can just leave it empty. Okay. So salary is attribute for works, right? So you're going to change works. So alter table works, and then you also add constraint. Okay, so then you can say check cell, and then check, and then put inside the parentheses what you need to check. So what you need to check is salary is null or salary is greater than or equal to 0. So that's what you need to check. Semicolon. So that's basically that's just each one of that is 1 point. Okay. And the last one is easy, just higher date, it's bigger than birth date. I'm going to skip that. Now let me know if you have questions. Okay, so now let's do the second part. Second question, 8 points. And I believe almost everyone did it right. So mistake, 1 or 2 students made a mistake. I think a mistake is on how to handle this weak entity. This is super type, subtypes. Everyone did it right. And for this one, you're going to have a many-to-many relationship between flight and flight. So you need to create junction table. And then you're going to have this weak entity. So let's just do this part and we move on, okay? So let me put this aside. Okay, so that way, so we're going to just say this part. We have more space on the wider board. Okay, so we are going to do flight first. The table flies. Let me think this. The layout is not very friendly for me to write note. Okay, I think this is probably better. So you're going to have a table flies. And that table has flight number as a primary key, and the description, optional data time, optional is not required. You're going to create a junction table for that. So you're going to create a flight number, repeat once, and the flight number So maybe this is like maybe like a what co-flight or code shell code something. So anyway, you can just name that in any way you like. However, this is going to be same primary key duplicated. So it's a flight number duplicated in here. And then there will be two foreign keys, this one and this one, okay? And they both join together, jointly together to make the primary key for the junction table. And then you're going to have a table for scheduled flight, scheduled flight. Okay, and that is weak entity. So first of all, we are going to get as date, schedule date. I think schedule date is marked as like a partial identify. So you're going to make that a part of a primary key. And then cap, this is optional. And then you're going to get the flight number as a foreign key, as well as a part of primary key. So this must be required because it's a part of a primary key. So primary key for scheduled flight consists of two columns, as date and also flight number. So that is reflected when you come into the junction table between reservation and the scheduled flight. So for the junction table, you're going to have RID and also primary key for scheduled flight. So let me just put that here, okay? So you're going to have RID as one foreign key. Another foreign key will be schedule as date and flight number together as second foreign key. Okay, there's a junction table, and then all together we'll make a primary key for the junction table. Okay, so I missed, I do not have a reservation table yet, but you can just do that for reservation table. I don't think anybody made a mistake on that. So I'm going to skip this one, so see whether you have any questions. Okay, so if you make any errors, for example, this is supposed to be junction table, you do not have the junction table, you just treat that as one-to-many, probably 2 points will be taken off. If you do not handle this weak entity correctly, that 2 points will be taken off, okay? And if you do not handle subtypes correctly, 2 points will be taken off. So basically this is how the grade is awarded. All right, and that's, okay, I think there's a normal form question. This normal form question is a pretty simple one. I did not put like a thought or Boy's Card normal form because we do not have enough exercise on normal form, on Boy's Card normal form yet. So here, the question is asking you to say whether this table violating second normal form. So for any of these normal forms, you first of all use your common sense, use your knowledge of how records are related. That what's called a cardinality thing. Okay. So here the question is, I think it's already said here. So assuming that each employee may work in different projects, so that means one employee can have different projects, and of course each employee. Okay. And then what is that? Following table manage assignments of employees into various projects. Assuming each employee may work in different projects with different assigned titles. Okay. Then the common sense here is a project, of course, can have multiple employees. One project have multiple employees. Okay. So to identify, to determine whether it's a violation of the second or third normal form, first of all, we have to decide whether it's the first, it follows the first normal form. And since there's no repeating data anywhere, right? So every cell just have single value. So therefore, that is not a concern. So only concern we have is now second normal form, whether we have partial functional dependencies. So now let's say for this table, we based on our knowledge, based on assumption that I think I can draw it right here also, right in Microsoft Word. So the primary key is going to be project number, and also employee ID. That's based on based on knowledge that one employee can work in many different projects. One project has many employees, so basically you have a many-to-many relationship. So therefore, in that case, the primary key, you have to use both department number and employee ID, right? And now let's say whether there's any partial functional dependencies, and it's very easy to say that project number will determine project description and also project priority. So in other words, these two columns does not really depend on employee ID. So therefore, this is a partial functional dependency. Similarly, employee ID also determines employee name, and not this one, not assigned item. So this not okay. So just employee name. So therefore, this table is not in second normal form. And to fix it, we need to write every part of the primary key one by one. So we have project number that determines description, project description, and also project priority. Okay, and then you're going to have you also have second functional dependency, which is employee ID. That determines employee name. Okay, so we have two parts, and then all together is also considered as another part. So project number and the employee ID, that together will determine assigned title. Okay, so that is clear. So same employee in different projects may have different titles. Okay, so therefore you have those three functional dependencies, and then based on that you create three tables. One table consisting of project number, and that is primary key, and also a project description, and project priority would be non-key columns. And then second table will be for employees, employee ID and employee name. And the third table is actually like a gerund. So if you try and draw ER diagrams, does it require ER diagrams? No, it does not. So then you just stop here, okay? So you end up with three tables. So this is actually the third table that that's just like a gerund between projects and employees. Any questions on this one? And the last one is open-ended question. So let's take a look. So what are the objects we should identify and how they are related? Okay, so here's how many points? I think it's 7 points, right? Yeah, 7 points. So let's read the question here. So first of all, we need this UH hospital has recently decided to develop a new database to manage their patient admissions. Okay, so admissions, right? And discharges, all right? And then hospital handles two types of a patient visit. I think at one time I talked about in PowerPoint, I emphasized that. So this patient, so two types, subtypes. So this actually is just a visit, not a patient. Patient is same patient. So today the patient may be outpatient. Tomorrow when the patient come back, maybe inpatient, right? So, but the patient record should be the same. So in other words, we are going to have the same patient record. So that you should not make like subtypes. You should not make inpatient, outpatient as kind of a patient. That's not the right way, not a correct way to do it. So rather, I should treat that, make that as a visit, and then we have inpatient visit. And outpatient visit. Okay. So let me repeat. So patient is going to have a patient ID, patient last name, first name, right? Okay, some other things, phone number, email address. So this is going to be same patient. This patient may be coming to the hospital one time as inpatient, as other time with outpatient. So we, it's not correct to classify this patient as inpatient outpatient. Instead, the visit should be inpatient visit, outpatient visit. So that may be what is more appropriate. Okay. And then you are going to you're going to have that as outpatient, inpatient. Each time when a new patient comes, the data about his identification ID, address, phone, admit date, and insurance policies will be recorded. So let's just say that name, address, of course, should go to inpatient, and insurance policies, I will probably make that as a weak entity. Weak entity. Insure policy. Why? Because one patient may have multiple policies, right? Some may be primary, secondary, but one policy is only for one patient, right? So that is, you can consider as a weak entity here. And then admitted date. So admitted date, that's just simply just attribute for a visit, right? Admit date. Maybe just attribute here. That's optional. Okay. And note that sometimes a patient may have one primary insurance policy along with some secondary ones. So that's why put like a weak entity here. So that's just like a multi-valued attribute. Say put insurance policies attribute, that's multi-valued. So therefore you need to make that as weak entity, right? And if patient is a resident, so inpatient, he or she will be assigned a ward, okay? After the treatment, and his or nurse or doctor has to sign off the discharge and record the discharge date. So for inpatient, you are going to have attribute like a ward, or maybe like a building, room number, something like that, right? Okay. Okay, and then how to handle discharge date. So discharge. So basically here, we're talking about each visit, each admission will have admitted date and also should have discharge date, right? So we can put discharge date as a common attribute. Does not matter that is inpatient or outpatient. So discharge date. So that second attribute should be common to a visit. Okay. Let me know if you have questions, okay? Otherwise, I will just do it like a brainstorming way that, just like what do you do typically when you do new questions like this. So your patient resident, he will be assigned with a ward, okay? After the treatment, so now the treatment. So isn't the treatment same as like a visit, right? So visit, treatment, you can just call different names, but should be same thing. Either nurse or doctor has to sign off the discharge. Oh, by the way, what about the discharge? So at this point, I put discharge date here, but then apparently this one asks you to have like a discharge also, record of discharge. So I'm going to just do that here. Create discharge. Okay. And then if that's the case, then I should put discharge as like attribute in discharge date, date discharged, date discharged, okay? And then, so we can attach a visit to discharge. So that discharge may have some other things, for example, doctor, like some kind of a signature who signed it. And so that is just, not just discharge date, but actually it has discharge date and some other attributes. The relationship should be what? One-to-one, right? One visit, one admission, as one discharge. One discharge is for one visit, right? So it does not matter whether it's inpatient or outpatient, you're going to have discharge. All right, so now we have a question about nurse, doctors. How do we handle that? I think some of you did that as like a subtype. So both of them as maybe like a physician, right? Physician. And physician include doctor and nurse. That is okay. So then basically you can just attach discharge to physician. And one physician can sign off many discharge, but one discharge is signed by one physician. So now this handle that this physician can be either doctor or nurse. Okay, so either way. All right, now let's see anything else. And the record discharge date. For the outpatient or nurse, we'll set up a follow-up treatment. So here, in other words, for outpatient visit, we have to figure out follow-ups. So that's just another visit, right? So visit and visit, so the relationship should be just like a recursive relationship here. So I should do causal relationship between outpatient and outpatient visit. So that just happened to the outpatient, all right? So that could be one-to-one relationship, optional, one visit, one outpatient visit may result in another follow-up, and a follow-up is for follow-up one outpatient visit, right? So that will handle that. Okay, what else? Those will set up follow-up treatment. So if you wanted to know who did scheduled the follow-up, I think there's some of you put like a appointment. So here I sort of like make a visit as same as appointment. And then if you trying to relate the nurse with follow-up for each visit, then you can just connect to here. Okay. So one nurse can have many follow-up, something like that. Okay. And of course, the system needs to track the record of the previous treatment. So that's basically the recursive relationship should be able to figure it out, should be able to track which treatment followed which other treatments. And use data modeler to create ER diagrams for that. Okay. So I think at the minimum, those are the things mentioned in the text. Okay. Some of the relationships like this, visit has two subtypes. I think that was pretty clear. And the insurance policies and the follow-up, those are things pretty clear. Okay. And beyond that, if you want to make this better, I guess you probably have to throw another object like appointment, and that make because appointment may not be same as admission, right? So that might be even better than this one. Okay. All right. Let me see whether you have any questions. And what I look at this one, how I grade this one. That basically the way I grade this is, first of all, have you identified all those objects correctly? And that should be worth like at least 2 points, 3 points. Okay, depending on how much whether you missed any important objects. Secondly, the relationships. Okay, so you may have different kind of relationships, but as long as they make sense, I will not consider as wrong. However, if you have mistakes like cardinality errors, for example, if you do something like this, like a visit and the patient has this kind of relationship, many-to-many relationship, I will consider that you have an error, have a mistake, because one visit is only for one patient. It cannot be for several patients, right? Okay, so that then I'll look at whether you handle the insurance policies, there's follow-ups and subtypes for visit correctly. Okay, and then maybe if if I think that this is not appropriate, 1 point may be taken off. If I think that the way to handle follow-up is not appropriate, 1 point may be taken off, something like that. All right, that's it. That's all for the first midterm exam. I think you all did well. Average was like 80, was 81 something, right? 80 or 81%. And but then I also added 3 points to make make average to be like a B, solid B. Okay, so that I believe that that's good. That's good enough. Okay. Now let me say whether you have any questions about this exam.
No.
No questions. All right. So we can conclude that and conclude this exam. Don't save changes. Okay. So we are going to do database programming. So today we are going to cover very fundamental, very basic SQL. But before that, I will go through just simple concepts about programming. Some of you may have some other coding, programming concept background, but others may not. So let's just try to get some beginning basic knowledge about coding or programming. Okay, so the question we need to answer, what is programming first, and then what are the basic syntax? So basically we need to understand writing a SQL statement is kind of like a programming, but we need to understand something around that. So what kind of SQL programming we are dealing with. So let me use PowerPoint to show those basics instead of using whiteboard to write everything. Okay, so we have no, not this one. I think we already reviewed your homework 5 or 6, 5, right? Before the exam. So I'm going to skip that. Now, what is programming? So to understand that, we need to understand that the computer is basically a very dummy device. What dummy? Basically, it's not that smart. You don't think a computer is that smart. Okay, computer is just basically made of, the CPU, the central part of computer is made of thousands or millions or billions of micro switches. Switch can be on or off, right? So when you're turning on, many switches to on or off, you can actually make many different patterns, right? So on, off, on, there have many different kind of this kind of patterns. So if you use on to represent the number one, and off to represent number 0, then each pattern is actually represent a binary number, right? And that's how essentially the CPU is actually just by manipulating the switches on off to create different patterns, to create different binary numbers. Okay, so essentially essentially programming is just basically control how manage the CPUs to turn on switch on or off in a logical manner, so that we can ask the CPU to perform some kind of operations or calculations. Okay, so that is the essence of programming. All right. Of course, if we have to do it manually, that does not make any sense, because that would be simply just probably slower than just by doing hand calculation, right? So we basically have to ask a computer to do that themselves. Ask a computer to do it itself, to turn on switches on or off based on we just give instructions, okay? And the computer will follow the instructions to turn on or off the switches. All right. So so a program is basically basically essentially consists logically sequence of instructions to the computer. And so now we understand the computer can only understand the zeros, ones. However, we human beings typically do not understand the zeros, ones. Okay, those are binary numbers. It's pretty. You can consider that as kind of boring patterns. But that is what the computer can understand. So our human beings like to use some kind of English-like commands to program the computers, to instruct computers to turn on switches, turn on switches, turn on or turn off the switches. So there's a gap between human and machine languages, okay? So machines speak zeros, ones, we speak English, okay? And that gap is filled by so-called programming language and a compiler. So first of all, computer scientists were invented or some kind of artificial language like a C++ or Java. Those are called programming languages. And that is very close to our human natural language, but it's more precise and more strict, more concise, and does not have ambiguities. So it's more very structured language, okay? So that is programming language. Along with the programming language, so when somebody invented a new programming language like C or C++, he or she has to design another software device that will automatically convert those languages into zeros or ones. Okay, that device is called a compiler. Okay, so basically you need a compiler to convert to translate human command, the English-like commands into 0, 1s, which is executable code. So this executable code just basically tells the machine to turn on or turn off those switches. Okay, so this is what the compiler is doing. It's just like a compiler is just more like a machine translator. Okay, so a programming process typically first, the 3 steps. You first use the programming language, and you use the language, use that to follow the syntax. You use that language to elements to write instructions. Okay, and then that the result is called a source code. Okay, and then your compiler is going to convert that into executable, and executable can be saved and then can be executed in the future. Okay, so when a programmer write a source code, and then he or she will compile it into the executable, and he or she will give the executable to the end users and ask end users will run those executable. Okay, so he or she, the programmer is not going to give out his source code. Source code is more representing his intellectual right. So that he or she will not give you the source code. Instead, of give you executable code. So executable code is a conversion result by the compiler. Okay, and then the user will run the executable. So basically, the executable is basically just performing the same kind of instructions that the programmer intended for you to perform, but it just don't say what is original source code. Okay, and then regarding compiler, we understand that's a machine translator, and then we have to follow the programming language for the translator to be able to translate. Okay, and then the language must be precise. We already said that. There should be no ambiguity, no fuzziness. It's unlike a human language. Our human language, like our English, sometimes one sentence may be interpreted in different meanings in different contexts, right? But here in programming language world, there's no such ambiguity and fuzziness allowed. Okay, and then the instructions you give in the programming language must follow the grammatical rules, and those grammatical rules are called syntax. Okay, so just like when we use English, we use a natural language to communicate. We also have to follow the syntax rules, right? Grammatical rules. So, for example, when I have a sentence like "I love you," I have to have like a subject, then verb, and object, right? So, and also the verb must be consistent with subject. So those type of things must be also followed by when you write a code in programming language. They must also follow the syntax. Okay. If you violate the syntax, then what happens? Then your compiler will not be able to understand your instructions. And then the compiler will spit out error or warning saying that, I don't understand, I cannot translate this. Something like that. Okay. So the errors you get will be the one detected by the compilers. Okay, so when you're doing compilation, so when you have a source code, you compile it, you get errors, and those errors are actually created by the compilers, not by the computer. Okay, computer does not understand anything you write, or programmers write. So it's only compiler which will be able to understand the instructions you write in that particular programming language. All right, And then there's something called interpreter, which is similar to compiler. The difference is that the interpreter will play will does translation and also will does that on the fly. So basically, when you have a source code, and the interpreter will come along to interpret your every instructions, and at the same time will run those instructions along the way. And so you will not save any end result as executable to be passed to the end users. Okay, so the interpreter is just like a compiler, but a compiler will save some kind of executable for the code to be executed later. But the interpreter will just simply interpret every statement, every command you have, and run the commands along the way. Okay, so we have when you have the exam, you have experience with web browsing. So web browsing, all web pages are written in in a programming language called HTML, so called a markup programming language, hypertext markup language, or JavaScript. Okay, so in that case, your web browser is actually acting as like an interpreter. So every time when there's a new line of code in HTML or JavaScript, the browser will interpret it and also run it. Okay, and then for example, the code maybe just say, I want to get display this picture, or I want to play this sound, or I want to just make this font to be bold, or I want this font to be in different color. So all those will be interpreted by web browser. The web browser will interpret the source code and then display the result right away. All right. And SQL is actually similar to that. SQL statements will be also interpreted, but this time will be interpreted by DBMS like Oracle. Okay, so it's not compiled. So in other words, when you write SQL statement, you don't use compiler to save executable and then run this executable later. Instead, so every time when you create your statement and then you run the statement, RDBMS, Relational Database Management Systems, will interpret your SQL statements and also run it at the same time. All right. So there's a little bit somewhere in the between that is you say also like the advanced DBMS like Oracle, which will actually cache your interpreted SQL statements in memory for future reuse. So for example, when you write SQL statement, and then the SQL statements may be repeatedly executed many times. So Oracle will detect that and then trying to save that interpreted result in the cache. And then in the future, if you need to run these statements again, and then there's no need to reinterpret the SQL statement. And then instead, you just simply use that what is cached to run it. Okay, so you can just imagine that this is kind of somewhere between compilation and interpretation. Okay, so that's how Oracle can improve the performance of executing SQL statements in this way by using cached passed result or interpreted result. All right, and so that's general. So far we talked about general programming, programming compilation, all that. So now let's come to SQL. SQL is a special kind of programming language, right? So SQL was initially developed by Chamberlain, Boyce. Does it ring a bell? Boyce. And also, so when these people were in IBM, right? When they heard about the relational model was created by Card. Okay, remember Boyce, Card. Okay, so here now you can just see those are the pioneer for relational database and also SQL. Okay, and then SQL version, the original version was created for a system, which is really not a relational database, kind of a quasi-relational database called a system now. And out of a system now we developed, for a system now, Oracle was created, and then some other relational database Sybase also created from that. Okay, that's original project. Okay, and SQL was standardized by international standard organizations like ANSI and ISO. I think. What we are covering, what we're teaching today is pretty much standard created in 1999. And then after that, there was some few newer standardization process. So most recent one, I think, is 2016. Okay. And then just a little bit knowledge about SQL. On the one hand, we have those standards, but now on the other hand, we have different kind of DBMS like Oracle, like Microsoft SQL Server, and then MySQL, and then what else? And also Microsoft Access. So different DBMS, they all claim to support SQL, but they support SQL to different degrees. So to my knowledge, Oracle is the only one that supports 100% the standard, 100%. So that's why we teach SQL in Oracle, right? But some other database like SQL, for example, Microsoft Access only support the entry level of the standard. So it does not support all level. So things we learned in here, some of them will be executable in Access, but not all of them, okay? So because it will support different, Access does not support the full standard, okay? And besides the standard SQL, each relational software company, each relational database also provide its own dialect and also extensions. So let's talk about extension here. So say Oracle, we have a standard. Oracle will support SQL standard. Besides that, Oracle will also have like extension called a PLSQL. That's called Standard Procedure Language Extension to SQL. Okay, so that basically that language is just like a C# or Java. Okay, allow users to write SQL statement, and also to before that or inside that you can just use the variables. You can also use loops. You can use you can also create functions or procedures or triggers. Those are just pretty much like a regular language, regular programming language beyond SQL. Okay, and then SQL. So that PSQL, there was a couple of years ago, some people were saying that PSQL should be standardized as the new standard for SQL, but that has not happened yet. And I believe some other companies may have objections. For example, Microsoft also has like a transact SQL as extension to their SQL standard. So it's debatable whether PSQL should be standardized or not. Okay, but just let you know that PSQL is actually allows you to do more than just SQL. SQL, remember, is non-procedural language. Okay, but PSQL is actually procedural language. So it allows you to get it to use find a different path to get the result instead of using just specify the result, specify the target. Okay, so that is something that we need to know about SQL extension. All right, so we talk about that SQL consists of a primary two set of languages. One is data definition language, which allow you to create tables, modify tables, and also some other database objects such as indexes, syntax, users, constraints, database links, right? Views, all that. Okay, so anything that's related to managing those database objects will belong to DDL category. And then the second category would be just managing data inside the tables. That is called the data manipulation statements. And as a matter of fact, there are a few more categories of statements which we don't really put a lot of emphasis. That include transaction control statements, session control statements, system control statements, and also we can do embedded SQL statements. Okay, let's skip that definition, data definition language and data manipulation language. Let's skip that. We already know that, right? So what about transaction? What is transaction? Transaction is typically database transaction is just like it's not just one single SQL statement. It typically consists of few, one or more SQL statements that work together. That is basically just like one unit, one atomic unit that perform a transaction. It's just like one unit. So in the sense that that all these SQL statements must be either performed or successfully or all failed. So if one failed, then the entire thing should be failed. So you should not just say if you have like a transaction consisting of 3 SQL statements and you run one successfully, other 2 not successfully, and that will not be allowed when you have a transaction control. Okay, so they must be either all successfully finished or none of them is done. Okay, so that is a concept of transaction. So transaction statements like a commit that will allow you to save, the result, or roll back if something happened. Let's say, for example, one of the transactions failed, then one of the statements failed, then you should roll back entire transactions. You're not, do partially committing. Okay, you should just roll back entire thing. Okay, and the save point is another comment that you allow you to, for example, I want to, periodically save transactions up to this point, and then if I roll back to this save point, something like that. Okay, so easy example for transaction is that suppose you do bank transactions, you transfer money from one account to another account, right? So what if you already took the money from one account, from the first account, but you did not put the money in the second account? So that type of thing should not happen, right? So that is what transaction control is supposed to do. So you make sure that either all of them done successfully or all of them fail. Okay. All right, and then session control. So basically, in a session is just say every time we log into Oracle server, then you just handshake and create like a login and create a handshake, and then you validate it, and then you start to use the server interactively, and then the whole time until you close the connection. That is called a session. So during that session, you can control as a database server administrator. You can use session control statements to control the session. For example, you can set the rule for the particular user. You can also set the auto the session. So using auto session statements. And then system control statements will control the whole system. Okay, the system consists of many login users, many sessions, right? So you can use that to control all sessions. Must follow this, same kind of things. For example, you can use a KO session, or you can use that to perform a task, so that every session will be infected. All right. Finally, embedded SQL statements also have a couple of things. So especially when we talk about put SQL statement into other programming language like a PLSQL, we talk about that, right? Or you can also put SQL inside a C# or Java. So in those cases, besides regular statement, you also have to use something like use open cursor, close cursor. Cursor is just like when you get the SQL statement, get the result, right? The result may be just temporarily stored in the memory, and that's the cursor, and then you can open it and then close it, and also you can fetch result one by one. Okay, things like those will belong to embedded SQL statements. All right, so now after we finish SQL, so programming SQL, and now let's say DML. So what we are going to focus the next few weeks will be on DML, data manipulation language. Okay, and the data manipulation language consists of primarily 4 statements. So what time is it? We still have like 1 hour. Okay. 4 statements. So basically, select statement, which will be used to retrieve or summarize data. So remember, it's not just retrieve data, but also summarize data. So a lot of times we are dealing with so-called online analytical processing, or maybe say data analytics using database, using live data. So we actually summarize data. Okay, I use data for calculations. So that belongs to select commands. Okay, so you're going to use select command to retrieve data and also use data for calculations. Is that clear? And then whenever you need to create a new records, you will use insert statement. And on the other hand, if you have existing records, you want to get rid of the records, get rid of entire row, then you do delete. Okay, and then somewhere between that is update. So update is working on existing record, but you are changing the values of some columns of the records. So in that case, you do update, modify. Okay. So in that you have 2 special cases. For example, if you already have a record and you want to get rid of some values in the record, that's update. That's not delete. Okay. Or other case, you have a record, but some records may have no values, and then you're trying to put new values into those cells. but that is also update. That's not a create. So when you do create the new records, you actually create a brand new records, entire row, okay? Delete, you delete the entire row, all right? So update is actually working on existing rows and changing some values only. So that is so-called action, okay? So when you're writing an SQL statement, first thing you want to do is you want to make sure that which action you want to take. You want to select or insert or delete or update. So that you must be clear, okay? Second, now this is, come to that, okay? So when you're writing an SQL statement, okay, so SQL is non-procedural language and it calls for precise specification of what to be done. So any SQL statement must have the following basic items to complete. First, type of action, like what I just said, okay? Select, insert, update, or delete. That you have to select, you have to choose correctly. Of course, if I give you a query and then you pick up a wrong action, then that means you're totally wrong, okay? So type of action is wrong. And then you need to specify which table or tables the action will be acted on. That is very, very important, okay? So for example, if you're trying to retrieve data, which table or tables you'll get data from, so specify those tables, okay? If you're going to update a table, then which table you're going to update, okay? Or same thing with insert or delete, okay? So by the way, here I have said tables, but tables, when the only time you can have multiple tables is when you do select. So you can select data from multiple tables, but for update, for delete, for insert, you can only work on one table at a time. So just one table for update, delete, and insert. Okay. And then the third specification is the column. Which column you want the action to work on? Okay. So if you're going to delete, then of course all columns. So you don't need to specify columns. Okay. But if you want to select or update or insert, then you have to specify which columns you want to have. You want to get data from, or change data, or insert data. Okay, so columns must be specified. Finally, which records the action will work on. So for that, you typically use so-called where clause to specify. The where clause is specifying a condition. The condition or conditions, the condition will specify will allow you to filter the records for the action to work on. Okay, so four aspects must be specified precisely for each SQL statement. All right, so let's come to basic syntax here. So for example, when I retrieve data, so the basic statement is this: you select after from you have tables. You can have multiple tables. This is the only statement you can have multiple tables. Okay, say table 1, comma, table 2, comma, table 3, like that. Okay, and then you specify which columns that you want to get data from. Okay, now besides columns, sometimes you also use functions of those columns. So use the columns as like a parameter for calculations. You get a calculation result. So that's fine too. But make sure that you base the calculation on the column data. So basically, just in a simple way to understand that, you just want to I want to select get data from those columns. You specify which columns you want to get. Okay. So remember, action, select from the table, and then after select, you have columns, which column you want to specify, and finally, which rows, which records you want to get data. So that will be specified by where clause. Okay, so where clause is used to filter the data according to specific conditions. So after the where clause, you must define the filter conditions. Okay, so where clause can be optional. If it's option, if you don't have it, if you don't have where clause, then basically entire column data will be retrieved. Okay, and if you have it, then only those records that satisfy the conditions will be retrieved. So that is where. I think I misspelled here well, okay, E-R-E. Okay. So now let's see how DBMS will process your select statement. So actually, if you understand the programming language, there's something called a while loop. It's actually a while loop will be used. So this is the logic. This is how for example, Oracle will process your SQL statement. First, it will take one record from the table. Take one record from your table, okay? So from which table? That's the name, the from clause, right? The from clause will specify which table, right? And then just pick up one record. And then we check to see whether the record will satisfy your conditions in the where clause. Okay, if it's not satisfied, the record will be discarded. If it's satisfied, the record will be temporarily put into cache memory, put aside. Okay, and then it's going to go to the next record, find the next record, and then do the same thing. So check, see whether it's satisfied the condition. If not, discard it. If yes, put that into cache again. So and this will continue until all the records are selected and checked. So you see that it's more like a while loop process. Okay. Of course, when we write SQL statement, we don't have to care. We don't care about what is what is the execution plan by Oracle. So what kind of while loop is used. We don't even care. Okay, because we just need to specify what are the basic things we want. Okay. So here is an example. So here, suppose I have a table called students, which have a bunch of columns, like a name column, surname columns, lesson column, all that, right? So if I want to just get the first two columns, I will do, say, select name, select also a comma and then surname from the name of table, which is students. So that's how we get this statement. Okay, and then this is the result, because this time we do not have where clause. So basically all records in the table will be retrieved. So no rows are filtered, no records are filtered. Okay. Of course, you can choose different columns. So for example, I just want to get a lesson column or name column, or then in that case, you can specify what column is, you can have different way to specify the name of columns you want. Okay, so I want just a name column, that's the result. Okay, also no where clause, so entire row, entire record, entire column will be retrieved. If I want to get all columns, if I get all columns, instead of typing all the columns, names, okay, names, name, surname, all that is type all of them separate by commas. You can use a white star that is used to represent all columns. Okay, so then in that case, basically the entire table will be retrieved. Okay, so what about the where clause? So here's an example. Suppose I want to get all the records. I want to get all data from this table, but only for those employees who have those students who have age greater than 20. So in this case, the first one will be satisfied because age is 21. Second one is also 25 because we say age greater or equal to 20, right? But third one will be filtered out, right? Because that student does not have age greater than 21. And the fourth one is also filtered out. So everything else will be selected. So now we get this result. So we are selecting everything, all columns from students where age is greater than. So this is kind of like a where clause, filtering the records. All right, and what about delete? So when you do delete statement, you just simply say delete from the name of table, only one table, remember, okay? Because for you to delete, you can only delete the records from one table at a time. So you do not need to specify columns, because when you delete records from table, the entire record, no matter how many columns in the record, all of them will be deleted. Okay, so delete from table. And then you can also specify which records will be deleted. So that is another where clause using conditions to filter the records to be deleted. Okay, so only the conditions are met, and those the records satisfying these conditions will be deleted. What if you do not have this? What if you do not have this? Do not have where clause? So simply delete from the name of table. That in that case, everything in the table will be deleted. It's pretty dangerous, right? So if you have those kind of mistake, just use a rollback to get the data back. Okay, undo the dangerous action. Okay, so usually when you do delete, of course you delete specific records, not everything. All right, so remember no column specified, and also one data at a time. Okay. And then how does DBMS process delete statements? Pretty much the same thing, just scan each record, and if the record is satisfied the condition, and the record will be deleted, okay? Otherwise, go to the next record and do it again, check again. So it's also using while loop to process delete statement. And here is the insert statement. So when you do insert, you say insert into the name table is only one table at a time, and then you list the columns, which columns you want to have data to be inserted. Okay, So when you have those columns, then you will specify values for those columns. So you can only do one table at a time and one record at a time. So insert into that and then values. And then if you have multiple values, multiple records to create, then you have to do it again. You say insert into table and then values, okay? And then do it again. So you cannot do insert into table and then values and then values and then values, trying to put multiple values. That will not work, okay? So one record at a time, one table at a time. And there's also a situation that you may just say, you can skip those columns. You don't have to specify those columns. Just simply say insert into table, the name of table, for example, employee table, and then you provide the values. But in this case, you assume that you are going to insert the values to every column of the table, okay? And that column must be in the original order. So for example, first one is employee number, second one is employee name, and then you have to provide values to match those columns one by one, okay? So that in that case is more like a special case that you want to insert the records into every column. And of course, if you have a column does not have value, then you can just put a null. Instead of a value, you can put a null in there. It's missing. It means that that value is missing for that particular column, okay? Finally, update statement. So we do update also one table at a time. And then after that, you specify which columns the value you want to change. Okay, so for example, I want to change the first column, second column, and the case column. So you specify the new values. Okay, so column equal to value, and then comma. Column equals to new value, comma, blah, blah, blah. Okay, and then you want to do that for which records? You want to do that for particular records that specified by these conditions. Again, so these conditions will be filtering only those records, then those column data will be changed. All right, I think that's all the syntax, basic concepts about the programming. So for next, for now, after we take a break first, okay, we take a break until what time? 8:15, 8:20, 21, 8:22, something like that. Okay, and then we'll do hands-on lessons. Okay, so we just practice those SQL statements. All right, let's take a break. I'm going to temporarily pause. Okay. All right, let me get rid of this PowerPoint. I do not need a PowerPoint for the next hour. And so everybody, for this SQL programming, make sure you understand that you need to put your hands on, and you're going to make mistakes, and then you're trying to fix the mistakes, and that process, debugging process, is important for learning. Okay, don't be frightened by mistakes, and don't just simply watch what I do, because you're not going to learn how to code, how to program, if you just watch somebody do it. All right, so just put your hands on, and then I'm going to tell you. So first of all, open up a not a Visual Studio, SQL Developer. That same program we create tables. We use to create tables. SQL Developer, and log on to database. So I'm going to get rid of this one. Hold on. Close that. Okay. So log on, and then use user ID, password. I hope you do not forget. All right. So after log on, you're presented with like a query builder. So that is the place we are going to write a code, right? Okay. Has everybody logged in? And then I'm going to tell you to go to equals and equals here, and go to public place. There's educational tools underneath that. I want you to go to a place called script loader. right here, scripts loader. Okay, and then scripts loader, the very first one is create sample Oracle tables. So are you there? Okay, follow me. Move line by line until you see a place called create HR database. Do you see that? Create HR database. All right, and then selecting from that line all the way to the line before create guest login database. So select all those rows. All right, and then copy that. All right, and then you go back to SQL developer, paste it. See what I did? Now you select Mariana, I cannot hear you. Your microphone probably is not on.
No, I didn't know how you got there, but I figured it out.
You figured out, okay. Go to equals, go to public, and then go to educational resources. All right, and then copy that you find that HR, you'll see starting from create HR database, and then all the way to the place before create login, guest login database. And then select all SQL statements, and then you can run. So that will create all your sample database, including data inside those tables. Does everybody get that? Okay, so in the future, if you make a mistake, say for example, table data was deleted, and then you want to get data back, just come back to the same place. Okay. In some homework questions, you may ask to get different kind of sample tables, sample database. So you should be able to find all sample data you need from this script loader. All right. So when you're running this statement, make sure you select all of them completely. Don't just select. So this will be wrong. So if you select, you can just say if you just mouse cursor inside the statement and run, then the entire statement will be wrong, will be executed. However, if you select just like if you do something like this, okay, select only part of it, like this one, and it will actually select. It will run only the things you selected. So in this case, of course, it's not SQL statement. It's not a complete SQL statement, and this will not be executed, right? Because it's just like two words. No, it's not SQL statement. All right. So after you have that, you can just keep on running that a couple of times. First time you run it, may say have some kind of error message, say table view does not exist. But if you run again, you should have no errors. Okay. And now I can delete that, and then I can also remove this, clear the result output. Okay. All right. So now let's say we should have two tables to begin with. One table is called DEPT. Okay. And then second table is EMP. That's for employees. All right. And you should realize that this table have some kind of a relationship, right? So basically, what we did in the first period, basically just telling you, teaching you how to recognize, how to understand or how to connect tables. Okay, so basically here, the department and the employees, department has many employees, so therefore is a one-to-many relationship. So department number should be primary key duplicated inside employee. There we go. Okay. And also we have an employee number and a manager number, so that you see that same kind of data. So therefore this is probably like a foreign key also. So a manager is duplicated a primary employee ID. So basically it's a recursive relationship among employees. So when you write SQL statements, make sure you understand how the tables are structured. Okay, so that's how the first period of lesson, first period of class was basically telling you how to tell the relationship, okay, how to detect relationship among tables. All right, okay. Now, let's say if I need to, let's just a couple of us update the insert, delete, and update first, just simple ones. Okay, so suppose I need to create a new department, and then I will just say insert into, you know what, let me just type the create a question first. So you should follow me that also. So 2 dash lines means just comment. Okay, so that will not be a SQL statement, just comment, okay? So create a new department in Agron, okay? So let's say how can I do that? So insert into, and then name of table, DPD, and then we have location, right? And then we do not have a title, what is not title, the department name, but we should have department number, because department number, look at here, is not missing, is not optional, is not a null. So you have to have a department number. So we can put the department number here, okay? DPD number. All right, and then we say values, okay? So let's say first Agron. Okay, since your type inside a single quote text is going to be case sensitive, let me tell you that anything else is not case sensitive. For example, this table name, column names, and also these keywords, they are not case sensitive. Only thing that is case sensitive is the text inside single quote, okay? The text values. So for example, if you spell Agron like this, it's not going to be same same name as like Agron started with capital A and everything small letters, or you can just put all capitals, then that would be also different. So the values inside a single quote are case sensitive. Now let's just say create department number. Department number, let's say I want to make 50 here, okay? So let's run this statement. And now you should get a 1 row inserted like that, okay? And remember how you're going to check the values, check data inside the table. Just say select star from DEPT. And then you will be able to see that then the new row is created in here. Okay. Now let's say in this case, I have no department name for department, and let's say I want to add a new department name here. So which command we should use? Update, right? So we need to change this department name to something else. Okay. So let's just say add the name to department 50. Okay. So we'll do update, and then update what? Update DEPT, the name of table, and then say set, and then the D name, that's name of column, equals to, let's just make a new name, so this is a production, okay? Okay, and then if we need to change something else, then we comma. Let's just say I want to make Agron, make this, get rid of this location. So I say log equals to null. We can do that. So we get rid of this Agron. So then the value will be missing, okay? And then we need to specify, we are going to change these 2 column values for which record. We are going to do for this one, for the last row. So how do we specify this last row? We can either say that this department number equals to 50, or we can also say that location equals to Agron, because there's no other locations with equal to Agron, right? So we can do either way. So we'll say where, and then say log equals to Agron. So again, this is case sensitive. So if you change this to, for example, Agron like that, you will not, the records will not be updated, because there's no department with location like this, with Agron, with small letter ON, okay? So if you all use capital ON, then it should be okay. Does it make sense? So this row is updated, and now let's just say that I'm going to select. So we can just run the same statement here. This statement here. So now this is a production department name is added, but location is removed. Okay. Now how do we do delete? So let's say if we want to delete, that last department. So delete from what? Delete from DEPT, okay? And then if we stop here, then basically every department will be deleted. Of course, that's dangerous. So we have to specify that particular records to be deleted. So let's say I want to delete this operation department, this department 40, okay? So I can say DEPT number equals to 40. So remember, we have numbers. Don't put numbers inside single quote. Only place you put single quote is when you have a text. And also data time. We're going to get data time second. Okay, so let's try to do that. I don't think we can delete it because this department may be also referenced by employees. Let's see. Yeah, actually, it's deleted. That's interesting. It's deleted. So there's nobody in the department 40. There we go. So department 40 is gone. Okay. All right. Now let's try and do one more. Let's say I want to create a new employees inside a department. Okay. So let's just say add Lisa to the employees to EMP table. Okay. And Lisa's job title with job equals to clock, job title, clock, and the hire date, the current date, hire date as the current date, current, so meaning today's date, current date, okay? All right, so that's the question. So now let's say if I do insert, let's try it both ways, insert into EMP, okay? And the first approach is basically specify what columns we want to do. So let's say I have an employee name, so that's E name. Okay, and also have job title, and also have a hire date. Okay, so those are columns we know, but then everything else we don't know. But we do need to have remember employees, that the employee table, employee number is required. So you cannot leave that empty. So we have to have employee number also. Employee number, okay? Now values. So now the values must be matching those, right? So first is E name, that will be Lisa. And the job title is clock, okay? And the hire date is today's date. So now let me tell you two different ways to specify date, okay? The first is using Oracle default data format. That format is using single quote to surround the data value. And that data value will be specified 2 digits for year for date value. For example, 12. And then 3 letters of month name. For example, June, like that, okay? And then 4 digits for year number. Let's say 1987, something like that, okay? But no, that's not today's date, right? So today's date is October 14th. So let's just change that. October 14th, and then 2020. Okay, so that is Oracle default format, okay? And then for employee number, we have to make up one, or we can just use a sequence number. Remember, we can use auto number generator to generate that. So I will tell you how to do that, okay? So this is a new record created. So let's run that. Okay, so one row added, okay? Now, the second approach for getting to today's date, actually we can use computer's system time to get today's date instead of using that, okay? So I'm going to just copy this instead of typing whole thing. Okay. So instead of this, that's a literal data value, I can just type sys date, like that. Of course, you cannot run this statement again because you cannot have same sequence, same employee number repeated, right? So I'm going to tell you how to create a sequence and I use that, okay? So remember, create a sequence. Okay, and see sequence, and the name of sequence, let's just say the name of sequence is EMP number SEQ, okay? That's just a name. And then for that sequence, you will say start with let's just start with 2009, 9002, and then increment by, let's say, increment by 3, okay? So the first number will be 9002, second number will be 9005, so on and so forth. We learned how, we did that, right? We don't learn how to sequence, how to do sequence, okay? So here, we can just use that instead of actual number. So we can do EMP number, SEQ dot next val, next value, okay? So that will not be a problem because if you use sequence, then every time you're going to get a new unique sequence, new unique employee number. So run again. I know that you're going to have some kind of problem here. The sequence does not exist. Okay, this statement was not created yet. Okay, so run that statement first. Okay, now they run the second statement. Okay, so now it's inserted. Okay. All right, so what if I want to insert this, use that without specifying the name of columns? So let's try that. Okay, so insert into EMP. So I will not specify columns. So this time we have to follow, provide the value to all columns one by one according to the original order. The first one was employee number. So we have to say, we can do employee number underscore SEQ dot next val. SEQ that next value. Okay, so that's employee number. The second one is ename that we know is Lisa. Okay, and the third one is a job title that is also known, so clock. Okay, and then manager, we don't know the manager, so we can use null. Okay, null, replace that. Hire date, that is sys date. Okay, today's date. Salary, we don't know, that's a null. Okay, and then commission, we don't know, that's a null also. And what about the department? So department is also null. Let me just tell you, what if I put a department like department 40 here? Do you think that will work? Will that work? Yes or no? Department 40. Does department 40 exist? No, we deleted, right? So this is actually second referential integrity rule. That means if the value for foreign key value can be missing. For example, employee manager number is missing, right? That's okay. But if you're going to put a value inside, the value must already exist in the corresponding primary key column. Does it make sense? So let me show you, let me write that down. Okay, I think that's important. Is not this one. So let me just, right here, it's already there, okay. So we know that the referential integrity rule number 1, that is data type and size for the foreign key column must match the primary key column, right? So this is the second rule, second referential integrity rule. That is a value to be inserted into foreign key column must pre-exist in the corresponding PK column, okay? Does it make sense? Okay, so that actually has a couple of implications. So for example, you already, you're trying to insert department 40 into the employee, but the department does not exist, so that will not work. But we can use 50, right? We can use 50. We use 50 here, okay? But however, so this statement will be executed, okay? So row select inserted. However, at this point, if you're trying to delete department 50, you know that that's going to also violate the referential integrity rule, because if you delete 50, then this record, this 50 will no longer exist in the primary key column, then this will not work. So for example, if you try delete from DEPT and where DEPT number equals to 50, then you're going to get an error message saying that you cannot do it because this department 50 is already used, okay? So that's also violating referential integrity rule. Does it make sense? Okay. So with all that, now let's do just follow the weekly outline. I'm going to do a bunch of select statements. The beginning part is pretty simple. So I will explain every statement and then make sure you practice it at the end of the class. And then from next week on, I will ask you to say, I will do one example, and then you will do 1 or 2 examples, follow that on your own as a way to reinforce the example. Okay, so I'm going to just follow the examples today. So that's week 6 outline. And then here we have a bunch of simple SQL statement here. So I'm going to copy one by one, okay? So first example is find employees whose salary is more than 800. Okay. So I would dash, and then put a question here. Okay. So this question is asking you for employees record. So where we get that? That's from employee table, right? So we select. And then from where? From EMP, that we know, okay? And then find employees. So now you need to decide which columns which columns signify employees. So of course, employee name, right? Employee name will be definitely necessary. And maybe employee number also necessary, right? So that just say those columns signify employees, okay? And then we do that for all the columns or just for some employees? We do just for those employees whose salary is more than 800. So therefore, we probably want to also show salary as the result to verify what we get. And then we need to specify where clause, where salary is bigger than 800, like that, okay? So this is a very simple example, right? So get those are the columns signifying employee records you want. And then from this table, and then this is a row selection condition. Okay, so if you get lost, you need to let me know. Okay, otherwise, assuming this will be something simple. So run that, and now you get those records. Okay, employee number, employee name, and also salary delayed. So all employees must have salary bigger than 800, right? So pretty simple, right? So let's do something similar to that again. So second one, I want to find the employees who were hired after 1980. Okay, so let's copy that question into, so let me get rid of this. Don't have whiteboard, close. And this is, okay, we need that. And dash, put a question here. Okay, so again, basically we just need to find a column signifying employees, and then we need to also have hire date, okay? So how do we do that? Let's just look at the original table. We could describe, the table structure. We have a column called a hire date. So we need to use hire date to determine that the employee is hired after that, right? So let's just say select E name, okay? And then employee name, and then what about employee number maybe? Okay, employee number. And then we need a hire date, okay? From EMP. Well, hire date after, that means greater than, okay? So how do we say that is 1980, after 1980? So this is we say how, okay? So standard format, okay, default format. So let's say after 1980, we may just interpret that as 31st December 1980, something like that, right? Okay, so this is hire date after 1980. Okay, now, so we get those results. Okay, so those are employees hired 19. Now, if you look at this result, you probably will wonder, this is, November 17th, that's clear, but 81, is that 2081 or 1981 or 1881? It's not clear, right? Okay, so actually this, some of you probably already heard about the 2K problems. That was 20 years back, Well, before 2000, all the computer scientists, programmers probably just thought that, human life will not pass 2000. Okay, after 2000, computer will not, people will not use computers anymore. So So before that, all the days, in database or in computers and everything, all the data was using 2-digit, like the last 2-digit, like 81 or 95, something like that. So after you get to year 2000, then all of a sudden we have to face that problem that should we interpret that 95 as 1995 or 1885 or 2095? It was not clear. Okay, so that was like a huge problem for computer industry to conquer during the years. Okay, so you say that this is kind of like is coming from that same kind of problem. So that the year was displaying only 2-digit instead of 4-digit. Okay, but internally, since the year 2000, Oracle has fixed the problem. All the days actually stored inside the database as 4 digits. But it's just when you display it, it does not show you 4 digits. Okay, so how do we get the 4 digits? Okay, so for that, I'm going to show you 2 functions. One is toChar. Another one is toDate. Okay, toDate. toChar allows you to get to show a date in a certain format as a text. So this will convert date into text. Okay, and the toDate will allow you to convert any text into date. So I'm going to use this in this same example. Suppose I want to display this hire date using long data format. So I will do select ename, emp number, and then for the hire date, I'm going to toChar, convert that to char hire date. And then we specify the format. So format, say I want to just get the year number. So I will say Y, something like that. Okay. So let's just do that first. Okay. And then from emp, and then hire date. So let's say, suppose I don't use this standard format for date. I use some other kind of format. So in that case, I have to convert that format into date. So first of all, hire date, and then greater than, and then say toDate. Okay, so we use toDate, specify the string. So for example, I want to use December 31st, 1980, like that. Okay, that is the format. Okay, that is text. I want to convert the text into date. So I need to tell Oracle that, the first 2 will be month number. So single quote and then and then the second 2 digits will be date value. So that will be DD. And then last 4 will be year number, Y. So that basically specifies the format for this text. And then that toDate function will convert that based on this format. Okay, so the format you provided. Okay, so now let's run this and you say, what do you get? Okay, so you get a 1981, right? Okay, so what if I want to get more data from this year? So you can just say, I want to get a month, complete the month name, and the DD, and then comma. So this will give you the complete month name. Okay, and let's run that again. So again, now you get a long data format like that. Or you can just use a month or DD. You can just get the day value or month value only. Or if you just want to have a abbreviation of the month, say MON, 3 letters, then you can do that too. Okay, so that would be just November 17, something like that. Okay, so those are the things you use for formats. Okay, month abbreviation for 3 letters, DD, day value, year value, and will be just a month number, like that. Does it make sense? So you can get a year number, you can get a month, you get day value. Okay, you can do that for any date. Okay, so for example, you can find like age, hire years, number of years the employee hired, right? So you can use the current system date to get a year, and then for hire date you can get a year, and then subtract, and you'll be able to get a number of years. Okay. All right. Any questions at this point? So basically, just all basic stuff, but to make sure you put your hands on, follow every example I did. Okay. And now, next question, I want to find employees who never received commissions. Okay, so let's put a question here. So all employees who never received commissions. Again, the first part will be the same. I just need to find out who the employees, maybe employee name also, or employee number also. Employee EMP number, okay? And then this time I want to know their commission, okay? From EMP, and how do I specify that employee has no commissions? Okay, so if I'm going to show you the original entire table, I think that was, let's just type it again. Okay, so I type it here, okay? So select star from EMP, from EMP. Okay, let's run that statement to get the entire table. And then you say that some employees, a lot of employees have no commissions. For example, King, that all these no employees, no commissions, right? But also this one has no employees too, right? There's two total salesman. That's 0 commission. 0 commission is also no commission, right? So how do we write this statement so that we will get those records that have no commissions and also this one? So we should say com is null, right? That's one case. The second case is com equal to 0, right? So we will do either way, right? Either this one or this one. So therefore we use or to connect them, okay? And the semicolon here. All right. So make sure when you use and or to connect conditions, each condition must be complete. So for example, if I type something like this, it will be completely wrong. So you say com is null or equal to 0. That will not be right, okay? Because after all, this equal to 0. What equal to 0? It's not clear, right? So you have to be precise. So com equal to 0 or something equal to 0, okay? And also in this case, can I use and, anybody? Instead of or, can I use and? So if you use and, you are just telling that find each record, this record, okay? And that commission column is null and also equal to 0. That's not possible, is it? That's not possible because the commission is null, then cannot be 0. It's 0, that cannot be null. All right, so in this case, you actually get no result, okay? So it has to be or. Make sense? So let's run it. Oh, something wrong. Can somebody tell me what's wrong? Oh, you identify something's wrong.
Spelling for EMP number is wrong.
EMP number, okay, right here, EMP number is wrong. EMP number, yeah. Thank you. All right, so we get that. Okay. Now let's do example 4. Find the salesman. Okay. Find the salesman who was hired after 1983. Let's just put dash first, okay? So that will make, oh, not this one. Here, dash. Okay. And so we find a salesman. So what do we need to find? Basically, we need to find the employee records, right? Salesman. So it's tempting for some of you to do this. Select salesman, and then from EMP, where hire date before, that means less than. Before what? Which date? I think I deleted that. So before which one? Before 1983, right? Before 1983 here. So how do we say 1993? So let's just use simple way to do that. That's January 1st, 1983. Okay. All right. So is this correct? Look at the salesman. So what should be after column, after select? You have to be exactly column name. So do we have a column like with that name? We can look at the original query here or original structure here. So we have employee name, employee number, job, title. Do we have a column called salesman? No. Okay, so that is wrong. All right. So we cannot say select salesman. So in this case, what it's asking for is trying to find employees, those employees who have a job title as salesman, right? So you're still looking for employees. So ename, okay? And maybe EMP number, all right? And maybe also job title. But then those job title must be salesman. So now we have a job equals to salesman. So it's a capital salesman, okay? But now, should we use or and in this case? We want to find employees who hired before that day and the salesman who hired before that day. So we actually have to find the employees who satisfy both. Those are employees. Those employees have job title as salesman and also hired before 1983. So therefore, we have to use and. Okay, so make sure you need to interpret the query result query in terms using right condition here. All right, so this one should be simple. Did we find it? Okay, this one. Okay, so those are the salesmen. Okay, and now let's do next one. Find the job titles. Find the job titles. So that should be simple, right? Just trying to find a job title. So you say select job from EMP, right? So in this case, you're basically trying to find all possible job titles. So you're not screening, filtering anyone out. However, there's a problem. The problem is that you say that job title salesman repeated. So how do we get just like unique numbers, unique job titles or distinct job titles? So in that, if that's what you want, just put distinct keyword in front of the column, so that way we'll suppress repetitive values. Okay. So then you're not going to get repetitive job titles. Only the unique values will be used. Okay. All right. So that is simple. All right. Next, employee question number 6. Okay. Number 6. So what does that do? Find those employees whose name starts with letter K. So in other words, you look at the employees, select. So you only select employee name, right? From employee. Okay, that's simple. But then how do I filter those employees? Just want to make sure that the employee name, has the first letter K. So to do that, you're going to use the pattern matching here. So basically say like what? The first letter is a K, and then say percentage sign. So percentage sign means anything after that, after the first letter can be anything. The first letter is a K. That's what it means. Okay. So just like a variation of this, suppose you want to find employees whose name has letter K inside. Can be the first, can be second, can be anywhere, or can be in the end. So if you do that, then this is how you do it. You're going to say anything before, anything after, does not matter, but there must be a letter K inside the name. So that is, when you do that, then just say contains letter K. And similarly, if you just say, I want to find the name which last letter has a K inside, the last letter is a K, ends with letter K, then that's how we do it. So basically anything before that, we don't know. But then after that, the last letter is K. So that is how we do use like and then pattern matching like that. Okay. So for our example, we just start with K. Okay. So now let's see. Then we find a Kim. Okay. All right. And now let's do example 7, which is pretty much similar to what we already done. Okay, so find all managers. Again, you're finding employees whose job title is managers. Okay, whose salary is more than 200. So again, select ename or maybe job title from EMP, where job title is manager. Okay. And also salary is more than 200 and cell is more than 200. 200. Okay. So in this case, find the manager who have that. So basically, the records must satisfy both. Satisfy the condition that job title is a manager and the salary is more than 200. Okay, there we go. So we found those employees. Pretty fast, right? So now let's do the last question here. And then we have about 10 minutes. So we can do one more example. Okay, so this one, I want to find analyst. So again, there's no column called analyst. We actually find employees whose job title is analyst and whose name ends with T. So this should be a simple one. You should be able to do it without my help. Okay, just do it. I'll see whether you have any problems with this. So find analyst whose name ends with letter T. Got it? So next week we'll be doing something like this. So after I give you an example, I want you to practice more additional examples. So basically, I will give you the question, and I'll give you like 1 or 2 minutes to finish, and then depending on whether you need my answer or not, I will move on. Okay. All right. So here, so basically, you are going to find employees also, E name, right? And maybe employee number also, MP number. And then from the employee table, well, the job title equals to analyst. Okay. And also the name ends with letter T. So like, so post single quote. So first part can be anything, but then T after that end with letter T. Okay, so there should be answer for that. Okay. There we go. So we have Scott font. Okay. Now all these examples so far are using just one table. Just one table. So now let me try to get you a situation, a query that I need to find employees using multiple tables. Okay, so let's say I want to find, so let's just make that as example 9. Okay, find employees in dollars. Okay, find employees in dollars. So again, we need to use employee table to find employees. So that is for sure, select maybe ename, okay? And then from EMP table, and now let's say I want to find those employees from dollars, but the employee table does not have location information. Now, if you look at employee, the table structure here, the employee table, the EMP table, have employee name, have employee job title, but there's no location, right? So we cannot use this table to decide whether an employee is in dollars or not. Does it make sense? However, we know that all employees have department, and the department will have location. So each department has location. So we should use 2 tables. We should also use DPD table. So we're going to this time we're going to use those tables. Employee table and DPD table. All right. And then we can say location equals to dollars. Okay. And then since we are using 2 tables, we have to tell this SQL statements that these 2 tables somehow are related. How? Primary key and foreign key values must be matching, right? So we have to specify this primary key, foreign key matching. So first, department.dpd number. So that's a primary key for department table. DPD table has this column. This column value must be same as employee tables at the DPD table, DPD number. Okay, so that basically just linking primary key with foreign key, matching primary key, foreign keys. Okay, so that way you not just simply just list many tables which have no relations. So next week we'll be talking about we're talking about a concept called join, and this is actually one type of implicit join. Okay, we are joining multiple tables. All right. So when you have 2 tables like this, 3 tables, more tables, doesn't matter which one first, say DPD first or EMP first. Does that matter? Theoretically, there's no difference. Okay, you get the same result. However, practically there is small difference. That is, in terms of running time, efficiency of running that SQL statement. You should do smaller table first, larger table next. So in this case, between employee table and the DPD table, you know which table is smaller, right? You definitely have a smaller number of departments than employees, right? So we can, for efficiency consideration, we should put department first and then EMP next, okay? So that is just pragmatic, practical kind of consideration, not really theoretical. So result will be the same either way. Okay, so same thing here. DPD table, the department number should do you have to have a department first and employee next? Employee next? No, you don't have to. You can just put employee.dpd number equals to dpd.dpd number. That would be the same thing. Okay, as long as this this check is the same, then you should get the same result. All right. And then we can run that, and then we should get those employees who are located in Dallas, like that. All right, I think I should stop here. Because we spent time to review exams, so this lesson I did pretty fast. I hope because they are basically simple. I hope there's no problem with you guys. So what I would suggest you to do is I uploaded like a SQL tutorial. That's like a tutorial I downloaded from the web from internet. I think it's called Tutorial Point, and you can just use that as additional help. And the chapter 19 has all the examples explained. So I think all the examples I did here should be explained there. Should be explained in there. Okay. So make sure if you have any questions, follow that. All right, and then make sure you do all these homework questions, and then if you encounter any problems, just make sure you practice a few more of the similar type of questions. So the beginning part is simple, and it's not difficult. But after, so when we come back next week, you will see that it's going to be, we have a growing complexity over time. Okay, so that's always the case when we do coding. We do something like a science or engineering type of courses. You start with something simple, and step by step, you climb up the ladder and get more complex jobs, more complex problems. Okay, but remember, all these complex problems we are going to deal with next week or week after that is going to be based on this simple stuff. So if you're very familiar with simple stuff, then you should have no problem with complex stuff, because complex stuff just put this basic stuff together, combining together to make a complex queries. All right, I think I should stop here. Let me ask you whether you have any questions. I'm going to stop recording for now.